Hello everyone. Today we will be discussing radical functions. So here we have two equations. Y equals the square root of x minus 3 with the 3 being outside of the square root, and y equals the square root of x minus 3 with the 3 being inside of the square root. The general equation for a radical function would be y equals a square root of x minus h plus k. And from this general equation, it can tell you a lot about the graph and the parabola. For example, A can tell you if the parabola will be stretched or compressed. Also, it will tell you if it is faced in the negative or positive direction. H will tell you the x point of the vertex and is always the opposite of the number. For instance, if the number was 4, then the point would be negative 4. And then K tells you the y point of the vertex. So just from this general equation, you can roughly predict the shape of the parabola. First, we must make a table for the first equation, which is y equals the square root of x minus 3 with the 3 being outside of the square root. The table will allow us to see the pattern and write out where the points should go in terms of the x and y axis. So once we set up this table, we are going to insert some numbers. So on the left should be x, in the middle should be y equals the square root of x minus 3, and the right should be y. So on the left, in the x column, we are going to insert numbers 0 through 5. And after this, we are going to plug in the numbers into the square root equation to see what it equals. Some of the numbers will produce decimals, and that is okay. Because this is a square root function, none of the negative numbers in the x column will work. This is also because in a square root, there cannot be a negative number. Additionally, when you graph a radical function, it would turn out like a sideways parabola. And because of this, it would not be a function. This is why you only draw the top part of it in order for it to be a function. So after we plug in the numbers, you should get the numbers shown at right. So for 0, you should get negative 3. For 1, you should have gotten negative 2. For 2, you should have gotten negative 1.58. For 3, you should have gotten negative 1.26. For 4, negative 1. And for 5, negative 0.76. Next, plot all of the numbers in the first table as shown on the screen. Notice that it hits the x-axis at 9 and the y-axis at negative 3. So we are going to plot our first point, start at 0 and go down 3. There's our first point. Now we're going to go to the 1 on the x-axis and go down 2. And now we are going to go to 2 and then go down 1.5. And then go to 3, go down a little bit less. And then for 4, it would hit negative 1. And from these points, you graph the function like this. Also, negative 3 on the y-axis will be your axis of symmetry, where one side would mirror the other. After you plotted the points, you should have drawn a curve through them, like so, and ended up with this shown on the screen. And this is how you graph the first radical function. Now we are going to begin on the second equation. So again, we are going to make a table. On the left will be x. In the middle, this time will be y equals the square root of x minus 3. And on the right will be y. And this time we're going to insert numbers 3 through 7. 3, 4, 5, 6, and 7. This is because if we entered numbers less than 3, it wouldn't come out correctly. So after you plug in these numbers into the equation, you should get the following numbers. For 3, you should get 0, 4, 1, 5, 1.41, 6, 1.73, and for 7, 2. Now we take these points and we plot them on a graph, like so. So now we look back at the table we made and plot our first point. So go to 3 on the positive x-axis and plot 0 on the y-axis. Now go to 4 and plot 1 and 5, 1.41, which is in the middle of 1 and 2 roughly. And 6 would be closer to 2. And finally, 7 is 2. And with your plots drawn, you can now create a curve following the plotted points. And you should end up with a curve like this. As you can see, the graph is very similar to the first one, but they have different x-axis location. For this one, it would hit at 3 on the x-axis, but does not hit the y-axis at all. This is because in the first equation, the 3 acts as the C, or the point where it hits the y-axis. So then we analyze the graph. They should not be the same because they are two whole different equations. Also, putting a number in the square root makes it even smaller, so it would produce a whole new number in comparison to a number that is outside of the square root. One of them includes the whole equation in the square root and one doesn't. They should both face the same direction but be placed in two different locations. In conclusion, they may seem very similar, but the difference between being in or out of the square root can make a huge difference.